This section is about radioactivity. It covers what is radioactivity, the effects of radiation on matter, and the uses of radiation. First, what is radioactivity? Radioactive decay is the random process that takes place in the nuclei of certain elements. There are three main types of radiation. Watch the next clip and make a note of what they are and what materials they can pass through.
These canisters hold plutonium. If the energy locked in them were released all at once, the result would be an explosion. So every canister is individually marked and accounted for. Under highly controlled conditions, nuclear power stations release the energy slowly to make electricity. The energy and radioactivity come from the plutonium nucleus. The nucleus of every atom is made up from protons and neutrons, about the same number of each. The nuclei of most atoms stay like this forever, but radioactive nuclei are unstable. They're like pieces of popcorn waiting to pop. Once in its life, a radioactive nucleus decays and throws out part of itself as radiation. Some atoms throw out a pair of protons and a pair of neutrons together as a particle. This is alpha radiation. In another nucleus, a neutron might suddenly change into a proton, throwing out an electron at the same time. This is beta radiation. Gamma radiation is an electromagnetic wave with very high energy. It's sometimes given off by a nucleus which has just decayed in another way, as the nucleus struggles to make itself stable. Atoms of the same type always decay in the same way, so it's often possible to work out what type of atom is involved by detecting and measuring radiation. The radiation is a telltale clue to the atom which created it. Alpha, beta and gamma radiation have different properties. Alpha radiation doesn't travel far in air. A sheet of paper will usually stop the alpha particles completely. Beta radiation is more penetrating. Paper has little effect. But beta particles find it difficult to pass through denser materials like perspex. Gamma radiation is the most penetrating of all. Only very dense materials, like lead, will greatly reduce gamma rays.
Alpha particles are positive helium nuclei and are stopped by paper. Beta particles are negative electrons and are stopped by perspex or thin aluminium. Gamma rays are electromagnetic waves with very high energy and are only stopped by lead. It may be easier to remember in a table like this, showing each kind of radiation, what they are, and what stops them. You can find a table like this on the GCSE Bitesize Physics website. Small amounts of radioactivity are all around us. This is called background radiation. Background radiation occurs naturally in some types of rock and in cosmic rays from space. We are also exposed to increasing levels of artificial radiation, from fallout from nuclear test explosions, leaks from nuclear power stations, and from radioactive waste from industrial processes. That's the end of what is radioactivity. Next, the effects of radiation on matter. If radiation enters our bodies, it ionises atoms within our body. This causes chemical changes and kills or damages body cells. This can also cause genetic defects, as radiation can alter the cell nucleus, changing the instructions for making new life, so children can be born with handicaps. Alpha particles do the most damage, as they are the heaviest and carry a positive charge. Beta and gamma rays penetrate further because they ionize fewer atoms along the way. But how does radiation get to us? Radioactive gas or dust can be taken into the body in the air, drinks and food. Radioactive material can also be dissolved in the rain and enter the food chain through grass. Once in the body, it cannot be removed. It causes cell damage and interferes with life processes. Some radioactive material can become concentrated in our bodies, such as in the thyroid gland, and radioactive organs can then irradiate us from within. That's it for the effects of radiation on matter. Next, some practical uses of radiation. There are several medical uses for radioactivity. Radiotherapy uses the damaging effect of radiation to kill cancerous cells while leaving healthy cells unharmed. Some scans make use of small doses of radioactive material introduced into the body to help doctors see what's going on. The next clip shows what's involved. Notice the safety precautions that have to be taken when handling radioactive materials.
2 years ago, a sports injury threatened to stop Gavin rowing. His doctor sent him for treatment that included a radioactive injection. The injection is made from a radioactive chemical element called technetium. It will travel through Gavin's blood to his bones. The technetium comes from a generator stored safely in the clean room.
This is the technetium generator that Seema was working with. I'll just take away the top. That's covered with lead shielding to keep the radiation away from the person operating the generator. What we've got inside is a column of molybdenum. This is continuously decaying into technetium. To wash the technetium through the column, we use some sterile sodium chloride, and the sodium chloride is sucked through the column to this sterile vial.
The hospital can use these radioactive materials safely because they don't stay strongly radioactive for long. The technetium injection will only produce strong radiation for a few hours, just long enough to do the bone scan. But the molybdenum generator which made it will last for about a week, long enough to make lots of injections.
If I'd been holding this amount of molybdenum perhaps 6 months ago, it would have been extremely dangerous for me. However, in that 6 months, it's decayed away and I can safely hold it.
We saw that medical staff handling radioactive material all the time wear protective clothes, work inside a special cabinet, keep the material in lead-lined containers, and use materials that decay relatively quickly. Technetium is a good radioactive source for medicine because it does not stay radioactive in the body too long. Technetium emits gamma rays, so the radiation escapes from the body without causing much damage. Alpha and beta radiation will be absorbed by the body, damaging the cells. Radiation has many other industrial uses. Leaks in underground pipes are traced by detecting gamma rays emitted from a radioactive substance. The thickness of materials can be measured by the amount of beta radiation they let through. Fruit is irradiated to kill mold spores and to stop the process of decay. Carbon dating can be used to work out the age of a dead animal or plant by measuring traces of radioactive carbon-14 remaining in it. Any carbon-14 must date back to when the organism was alive. So knowing the half-life of carbon-14 allows the age of the organism to be worked out. Similar techniques can be used to find the age of rocks. Natural radioactive isotopes were trapped in the rocks when they first formed and have been decaying over millions of years to form new elements. For example, over time uranium-238 decays to form lead-206. By measuring the relative proportion of the two elements present in the rock, the age of the rock can be worked out. There's more about radioactivity in the higher tier science programme. That's the end of this section on radioactivity.